Okay, we're going to talk about interest. So, simple interest. So, let's say we get an interest rate, an annual percentage rate, an APR of 5%. And we put in, let's say we're going to be saving $1,000, putting that much into our savings account. So, simple interest. So, at year zero, time zero, when we put in the 1,000, we'll have $1,000. Now, after 1 year, if we're going to get 5%, then we take 5% of 1,000, which is $50, 0.05 times 1,000 is 50, and we get $50 added to this, so we'd have 1,050. And after 2 years, seems like we should have 0.05 times this, but that's compounding. Simple interest, you just get the same interest that you got on the original balance again the next year. So after the second year, you would get $50 more, which would be $1,100. And then after 3 years, at $50 more, $1,150. And if we went down to 10 years, it'd be the 1,000 plus the $50, or the 0.05 times 1,000 times 10 years, which is 500. So we'd have $1,500 in 10 years. Then, so how long does it take it to double? Well, we get 500 in 10 years, so in 20 years, we would have another 10 years, we'd have another 500, and we'd have $2,000, and it would be doubled. Now, if we compound annually, in year zero, we would have the $1,000. After 1 year, we'd get 5% of that added on, so we'd have 1,050, and it looks like we're getting the same numbers, except in the second year, we get 5% of this number, not of the original amount. So we need to do 5% of this and add it to this. Now, we talked about this earlier in this class, how we can do that in one simple step. So if I type in 1,000 into my calculator or my phone or whatever and press enter, and then say times 100% and 5% more, times 105, and press enter, after 1 year I get 1050. But since it's set up this to take this answer times 1.05, if I press enter, it tells me how much after 2 years. And it says it would be $1,102.50. So now after 2 years, I make $2.50 more than I had on simple interest. Not a lot. And if I press enter again, there's how much after 3 years. 157 and 63 rounded off, which now I've gained $7.63 on what I did here. So it's starting to get a bigger percentage. And if I go to 10 years, that's 3, enters 4, 5, 6, 7, 8, 9, 10. I'd have $1,000 $628.89 in 10 years. So how long does it take to double now? That's 10, 11, 12, 13, 14, 14, it's almost double. 15, it's over double. So somewhere between 14 and 15, probably around 14.5 years. So let's now talk about what I just did. I did 1,000 times 1.05, and I did it 15 times. I did this, so I can go to the power of 15, and I should get the same answer. And I'm estimating 14.5 to double. Let's see if that's right. 1,000 times 1.05 to the 14.5, and I think that's going to be close to 2,000. Well, that's a little high. So if I just bring that back, and I'll change it to 14.3. It's getting closer to a double. I'll bring it back, and I'll change it to 14.2. That's really close to double. It's only 65 cents off. So it takes about 14.2 years to double. Okay, what if it was compounded monthly? Well, again, we'd have 0, and at the beginning we'd have 1,000 at year 0. Now you would think that we would just do compounded monthly. We'd do this 12 times. 12 times 1.05. But it's not 1.05 because every month we're not going to get 5%. It's only 5% for the year. So I have to take this percentage and divide it by 12. So to figure this one out, I'm going to have to do my 1,000 times 1 plus 0.05, the interest rate, but only 1/12 of that, divided by 12. That much interest per month. 0.05 divided by 12, because there's 12 months in a year, and it's supposed to be 0.5 for a year, so I have to divide by 12, close parenthesis. And that's what I get after 1 month. So I'm going to have to do this thing times this 12 times to figure out after 1 year. So I'm going to bring that back and say, do it 12 times to find out how much after 1 year. And I get a little bit more than the 1050 we had. We get $1,151.16. And then to do for 2 years, I'll bring this back, and I'm going to do 12 times 2 to make it for 2 years, which is now, instead of 1,100 on simple or 1,102.50, it's 1,104.94. $1,104.94. And if I did 3 years, change the 2 to a 3, I'd have $1,161.47. So for 10 years, I'd have to go up here and make this 10. So 10 times 12, I could just write 120, but I'm going to write 12 times a year for 10 years. And so that means I'm going to have $1,647.01 rounded off. So when does it double? Well, it's not that much more, but it is a little bit more, so it's probably going to take a little bit less. Let's see if it would do it in 14 years. So that would be 12 times a year, 12 times for 14 years. We get, it's more than enough. So it's going to be less. It's going to double in less than 14 years. So let's try 13 years. Nope, not enough. Let's try 13.5 years. Not enough. 13.7 years. Not enough. 13.9 years. That's enough. Just barely enough. Okay. So now it's 13.9 years we double. What if we compounded daily? So instead of waiting for a whole month to add our interest in and then get interest on the original amount and the interest on the interest, which makes it grow faster, we're going to do it daily. So how does that change? Well, this part is still $1,000. We still get 1,000 or 100% of that $1,000 and 5%, but per day we don't get 0.05 divided by 12. We get divided by 365. And so then to do 1 year, we're going to have to do it 365 times. We're going to have to multiply by this. And we get that the amount after 0 would be 1,000. And after 1 month, we'd have $1,051.26. Notice we didn't make much more, a dime in 1 year by doing daily versus monthly. So we're not getting much difference now. Going from annual to monthly, we're making a fairly significant difference, $4. But going from there to daily, let's see. Let's go for 3 years. That's 11.6182. So I got 35 cents more than I did compounding monthly. I got $3 or $4 more, $4 and something more than annual. I got $11 more than simple interest. So how much is 10 years? So I go back here and change the 3 to 10. And I'd have, in 10 years, 1648.66. And how long does it take to double? Well, since I'm not doing that much more than I did before, it's probably going to be close to 13.9, maybe 13.8. So I'll go up here and go 13.8 years, and it's not quite enough. So it's going to probably be close to 13.9 years again. I'll check it. change the 8 to a 9. That's more than enough. I got $3 extra. Before it was only some cents extra. So it's somewhere between 3.8 and 3.9 years. Okay? What if I compounded every minute? Well, it wouldn't do much. But down here, instead of 365, which is how many days, I'd have to, let's see, I'm going to put parentheses on here. And I'd have to do 365 days in a year times 24 hours in a day times 60 minutes in an hour. And so up here, I'd have to do 365 times 24 times 60 to get it every minute. I multiply by this, which adds the interest to the original amount. And so for 1 year, I would get 1,051.27. When year 0 is $1,000. Notice I got 1 penny more after a year by compounding every minute. And in 10 years, I'd have to take this up times 10, and I'd have 16.48 and 72 cents. So I got 6 cents more compounding every minute than daily. Not a whole lot difference. When you start compounding, it makes a difference. And the more times you do it, it makes a little bit better difference. But if you start getting to too small time periods where you compound, it's not making much difference at all. And let's see if we can compound it for not 10 years. How long does it take to double? So if we want to do 13 point, let's see if it can do it in 13.8 years. Not quite. It's still going to be close to 13.9 years. So now, how about doing it compounding every millisecond or microsecond or whatever? Well, that's almost continuously. And there's an alternative formula for doing that. Instead of doing all these numbers in here, we can do it with a formula that's the compounded continuously formula, which is the amount you would have after some time is equal to the starting amount, the principal, that's often called principal, times E, and I'll talk about that in a second, to the interest rate, R, times the number of years. We'll do Y. Now, if I do formulas for these other ones here, simple is pretty easy to do otherwise, but compounded, let's do monthly. We did the amount after some time is equal to the principal you put in, that's the $1,000, times 100% of it plus the interest rate, which we use R for, divided by how many times you're going to do it in a year. So if we're doing monthly, N would be 12. And then notice that we had to do this part times this 12 times. And then to do more years, we had to take it times the number of years. So this is the compound interest formula. And if we were compounding annually, N would be 1. The interest rate is our APR of 0.05. Sorry, bump that and move my camera. And if we're doing it daily, n would be 365. And if we're doing every minute, we'd have to figure out we would be doing 365 times 24 hours in a day times 60 minutes in each hour. And if we did it every second, it would be times another 60. That would be our n, whatever that is. And that would go here and here. And then for however many years. So that's the compound interest formula for doing any of these. N is 1, N is 12, N is 365, N is a messy number. Continuously, we don't have to worry about that. And we don't have to figure out this messy n, and this part to the nth becomes this part right there, e to the r, and then we take it times y. So e is a special number that makes this happen. And on your calculator, either on your phone or any other place, there is e. Not this double e that we were using to do times 10 to that, but this e. So let's do compounded continuously for our $1,000. And there's also an e down here, e to some power. Now we could do this and then say to the power, but it has it already set up, so I'm just going to use that one. Second, e to the interest rate, 0.05 in decimal form, times the number of years. So if it was 1 year, we get 51.27. Well, every minute is almost the same. So it's still the same after 1 year. After 10 years, it's probably not going to be much different. Put in a 0 on there. 10 years, it's going to be, again, 1648.72. Doing it every minute, it's almost the same as doing it continuously. And when does it double? It's probably going to be 13.9 again. Go to 13.9. And it doubles in 13.9. Does it double in 13.8? And the answer is not quite. This was 3 over. This is $6.3 under. So it's still about 3.9. So instead of doing every minute this way, it's almost continuously, might as well use the shorter formula. Now, E, I said I'd talk a little bit more about it. When we talk about circles, we use pi a lot, and it goes on and on and on and never repeats. Well, E is also a number that you find when you're talking about power equations. You use it a lot. And E, pushing this button second there, is 2.718281828459045. I've memorized it further than it shows on the calculator. So it's I don't even know pi to that many places, but I know E to more places. It's also easy to memorize. But anyway, that's interest formulas. Compounded continuously. This is compounded n times a year. If it was quarterly, n would be 4. And then simple interest, you just find the interest in 1 year and keep adding the same amount each year. Simple, compounded, and continuously compounded. Okay.